Okay, so what if my rational expression that I'm adding, what if they don't have a common denominator? Okay. Part of the reason why we did the least common multiples is because they're very similar to the least common denominator, which is what we need when we're going to add fractions that don't have a common denominator. So the first thing we need to do is find one. So we need to identify what the least common denominator is. We're going to multiply each expression by an appropriate form of 1. All right, so we get the least common denominator. And then we'll go ahead and do our adding and subtracting. Factor if we need, simplify if needed when we're all done. All right, so if we look at these two fractions that we want to add together. Now, one of the things you can do is you could simplify your fractions first if that's possible, okay, before you do anything else. And if you do that, then if they can both be simplified, then it makes it easier when you're done. There's less things to be simplified then. Right? So let's go ahead and look at these two. Is there, in the first fraction, is there anything I can simplify there? Okay, they both parts have an n. So I can rewrite the first one as 2 over 5n squared. Now, if we look at the second fraction, okay, can I simplify that? All right. I can simplify the 2 and an n, right? But the thing is, though, is that, notice, one thing is that we have n squared in that denominator. Well, our other denominator is n squared. So do we want to simplify the n? Or should we just simplify the 4 and the 2? Okay, just the 4 and the 2, because this allows me to already have my common denominator with n, or at least the n squared we're going to need. Okay. So we'll go ahead and leave that part. So we've got, I'm still going to have 2n in the numerator then, and I'll have n squared in the denominator. So I simplified the 4 over 2 is 2. Okay. Now, look at your two denominators. All right. What do they have the same? What do they have that's different? So they both have n squared. The one on the left has a 5, the one on the right doesn't. So I need to multiply then the right side by 5 over 5. So I then have a common denominator of 5n squared. So we have 2 plus 10n over my common denominator of 5n squared. And that's our answer. We cannot simplify that any further. We could take a 2 out of the numerator, okay, but 2 doesn't go into 5, so I can't simplify that. All right, it's done right there. Okay. So if you have a fraction that you can simplify, you want to do that at first if you can, but we still want to make sure we have the same to get a common denominator then. So what one has, the other one's going to need. Just like with the least common multiple stuff. What one of them has, the other one needs. So let's look at another one. 2 over 5 minus w minus the quantity of 5 over w minus 5. So these two denominators are different, but they're very close to each other, right? Okay. They're opposites. So I can factor out or multiply by -1, and that will change the one to be the same as the other. So we can, which one do we want to change? Do we care whether it's 5 minus w or w minus 5? Does that matter? All that matters is that it's a common denominator. So which one should we change? Nathan, which one should we change? The one on the right. And why do you want to change that one? Because why? Okay, you just want you like 5 minus w. Okay. All right, how many people like w minus 5? All right, you got one. So everybody else would do the 5 minus, change the w minus 5 also? Okay, good. So we've got 2 over 5 minus w minus 5 over, and this becomes a negative 5 minus w. So we factored out -1 so that it would change the signs on my denominator, w minus 5. Okay, so now what do we do? Because these denominators are not the same now either, are they? They're still not the same. Because the one on the right's got a negative in front of it. Is there a way I could change that so that it is the same then? No? So any candy you guys have had today has basically put you to sleep instead of made you hyper, huh? Oh, well, better stay awake then. All right, now, since since I have the negative here and here, what is that going to do? It's going to change it to being positive. So we've got 2 in the numerator here. These two make it positive, so I have plus 5 over 5 minus w. So my answer would be 7 over 5 minus w. We were playing around with it first hour to see what kind of different shapes it would connect, and it won't do some of them. Like if I try to do a triangle, oh, it did do it that time. Earlier it wouldn't, you know. Sure. So, but anyway, okay. So because we had opposites in our denominators, then factor out the negative, which would change the signs, and then that works really nice because it will have those two negatives make a positive. Easy to simplify that. What's that? Well, I tried to make a hexagon. I didn't like that. Let's try a star. That was close. It's just I didn't connect that one perfectly. Otherwise, it would have worked. All right. Close to working. All right. You like straight lines. All right. So let's try this one then. A little bit more complicated. prefer it when you're asleep. It doesn't help you any, but. Okay. Now, do these have a common denominator? No. All right. So they're totally different, aren't they? So that means I need to multiply the left side by x squared minus 6x minus 7, and the right side by x squared minus 13x plus 42, right? Okay. That would be a lot of work, wouldn't it? Okay. Is there an easier thing we can do to help make this a little better way to do it? Okay, so let's try factoring. So if I factor this one, we get x minus 7 and x minus 6, right? And if we factor the right side, we get x minus 7 and x plus 1. Okay. So do they have anything in common? Okay, they have an x minus 7. Great, that helps me. So then, what does the left side have that the right side doesn't? Okay, x minus 6. So that means I need to multiply the numerator and the denominator over here by x minus 6. What does the right side have that the left side doesn't? Okay, so we're going to multiply the left side, the numerator and the denominator, by x plus 1. So my denominator then is going to be x minus 7 times quantity x minus 6 times quantity x plus 1. Okay, there's my denominator. Yes? All right, does everybody see that? All right. Bruce says, how about if we factor this? You were trying to say that, Matt? You didn't want to interrupt me? Thank you for not interrupting me. Okay? All right. Oh, that helps, doesn't it? Because I can now simplify these two. So that changes things a little bit, doesn't it? Okay? All right, so I guess we probably ought to rewrite it before we go on then, shouldn't we? All right, so let's do that. Let me get rid of this for a second here. Okay. Well, I want you guys to see what's going on. I'm not going to tell you everything all the time. Okay? Now, so, let's start over again then. We've got 5 in the numerator on the left side, because we have the x minus 6 is gone, and x minus 7 in the denominator. Okay. On the right side, we still have everything there. 11 over x minus 7 and x plus 1. Oh, that makes it much easier, doesn't it? All right. So we need to say thanks, Ruth. Thank you, Ruth. Now, the point is, though, is that how many of you saw that I could factor that? Okay. All right. Matt, obviously. Mitchell, you saw it? Okay. All right. So you need to look for that to see if maybe if I factor that I can do it. But if you didn't see that, then you would have ended up doing what I started to do, right? Now, would you still get the right answer? Yeah, you would. You could still get the right answer. You have to make sure at the end, though, that you factor and then so that you can simplify it. Okay? But if you saw this right away, then that would make it a much easier problem, because now all I need to do is multiply the left side, numerator and denominator, by x plus 1. Now, it doesn't mean we would have got the wrong answer. It just means that we would have had a little more work to do. Okay? This helps it, makes it a little bit simpler. So now we've got 5x plus 5 plus 11 over my common denominator of x minus 7 times x plus 1. Then we simplify that. We get 5x plus 16 over x minus 7 times x plus 1. Can we simplify that? Do 5 and anything go into 5 and 16? No. Okay, so we're done there. So that would be our final answer. There's my version of a pumpkin. How is that? That's not bad, right? Especially for me, who is definitely not an artist.